All right, for today's lesson, we're going to look at two topics. And the first one is going to be, how do you find the derivative of the inverse of a function. So not just like if you had, let's say that you had f of x is equal to 2x plus 4. But not that I want you to find the derivative of this function. What if I want you to find the derivative of its inverse? So obviously the first thing you have to do is you have to find the inverse of the function. So let's take a pre-count. How do you find the inverse of the function? Well, let's say that you have the function y is equal to 2x plus 4. The basic definition of inverse is you simply exchange or change the x and the y. So the inverse of y is equal to 2x plus 4. The inverse of that would simply be x equals 2y plus 4. And those would be inverse functions of themselves. So let's go ahead and just take a look at an example. So if I wanted you to find the derivative of the inverse function of f of x is equal to 1/4 x cubed plus x minus 1. Let's say I want you to find the derivative of the inverse function. So the first thing I would have to do is I'd have to find the inverse of this function. So you probably think, well, I don't see a y. Well, yeah, you do. F of x is the same thing as y. So the inverse function would simply be x equals 1/4 y cubed plus y minus 1. And then to find this derivative, I would take it implicitly. The derivative of x would be 1 dx dx. The derivative of 1/4 y cubed would be 3/4 y squared dy dx. The derivative of y would just be 1 dy dx, and that would just be 0. Clean this up, I would get 1 is equal to 3/4 y squared dy dx plus 1 dy dx. And so I notice they have a dy dx in common, so I'll factor that out. So I get 1 is equal to dy dx, and that leaves behind 3/4 y squared plus 1, and then dividing both sides, I get 1 over 3/4 y squared plus 1 is equal to dy dx, and that would be the derivative. Sorry, that's not what I want. Let me erase that. So 1, 2, 3. That would be the derivative of the inverse of my function right there. 1 over 3/4 y squared plus 1. All right. The second topic that I want to talk about is approximating derivatives. And so sometimes you might not have a function. Sometimes the only thing that you have is data. More often than not, guys, in the real world, you're not going to just have a function explicitly said. What you're going to do in the real world, guys, is you're going to be collecting data. So let's say that you had data. Let's say that you had different moments in time. Okay? So let's say that you start off with moment in time. Let's say this is 1 second, and then this is 2 seconds, and then this is 2 seconds. Oh my goodness, I hate this Lenovo. All right, and then this is 3. This is, oh wow, now where'd it go? Oh, it just went away. Wow. It's great. Wonderful technology. Okay. All right, so again, let's say that you had some data. And let's say that you were measuring some moments in time. So 1 second, and 2 seconds, and 3 seconds, and 4 seconds. And let's say you were measuring the velocity of a car or a rocket. And let's say a car. And let's say at 1 second it was going 10 miles per hour. At 2 seconds it was going 20 miles per hour. At 3 seconds it was going 40 miles per hour, and then in 5 seconds it was going 65 miles per hour. So obviously it's accelerating. Let's say you wanted to find its instantaneous velocity at 2.5 seconds. Well, the problem is I don't have any data that. I can tell you how fast it's going at 2 seconds. I can tell you how fast it's going at 3 seconds, but I can't tell you exactly how fast it's going at 2.5. So could we approximate that? Could we approximate that rate of change? The answer to that is yes. The way we would do that is simply find the slope. So it's no different than what you learned in probably 8th or 9th grade. So if I wanted to approximate 2.5 seconds, the derivative, let's say I wanted to approximate its derivative 2.5 seconds. So in other words, I'm trying to figure out what's its acceleration at 2.5 seconds, because I can tell you what its velocity is at 2 seconds and 4 seconds, at 3 seconds. So then I can approximate its derivative at 2.5 seconds by simply doing 40 minus 20 over 3 minus 2, which would be 20 over 1, so that would be 20. And so then I would say that it's accelerating approximately 20 miles per hour. So that's its approximation. So again, that's how you would just do an approximation, is that you would just simply, if you wanted to find the derivative or slope at a point, then you would just pick 2 points to help you get an approximate answer for that point. All right, that's it for today's lesson.